Just past dusk, a single point of bright light pierces the twilight. It is the second brightest object in the night sky, outshone only by the moon itself. Early sky watchers saw it arrive with the morning and again at twilight, leading many ancient civilizations to record it as two distinct stars. Eventually, they realized this morning and evening star were the same planetary body. Captivated by its brilliance, the Romans named this sphere after that goddess of love and beauty. We looked up and saw our own ideals reflected in the dark. For millennia, that romantic projection obscured the terrifying reality of the world right next door. This image shows the silhouette of Venus transiting across the solar disk. By tracking this small black circle moving across the sun, early astronomers could calculate the scale of our entire solar system. During an 18th century transit, Russian scientist Mikhail Lomonosov noticed a fuzzy ring of light bending around the planet's edge. He had discovered that Venus possessed a thick atmosphere. Because it was swaddled in clouds and sat closer to the sun, scientists and science fiction writers naturally assumed that atmosphere hid a lush tropical ocean world, a twin to our own. When modern space probes pierced that veil, they didn't find oceans. They found a raging inferno, masked by suffocating sulfuric acid. The very proximity and reflective clouds that made it beautiful from Earth had tricked us. Expecting an oasis, humanity instead uncovered a toxic wasteland. To understand how that wasteland formed, we have to rewind 4.5 billion years. Earth and Venus coalesced from the same stellar dust, emerging as planetary twins with nearly identical size, gravity, and composition. In its youth, Venus likely resembled early Earth, complete with shallow liquid oceans, blue skies, and mild temperatures capable of supporting life. The two worlds shared almost everything, except for their orbit. Venus formed just a fraction closer to the young sun. As that star naturally grew brighter over time, Venus absorbed the excess heat. That tiny difference in orbital distance dictated the planet's entire future, turning a thriving cradle into a sterile furnace. As the sun warmed, Venus's oceans rapidly evaporated. This thick water vapor trapped escaping heat against the planet, boiling more oceans in an unstoppable feedback loop. Finally, carbon dioxide baked directly out of the dry rock, forming an impenetrable, toxic shield. Today, standing on that surface would feel like being crushed almost a kilometer beneath Earth's ocean, with an atmospheric pressure 92 times our own, and temperatures hot enough to melt lead. The orbital mechanics are just as extreme. Venus rotates backward compared to most other planets, and it spins so slowly that a single Venusian day lasts longer than its entire year. When the Soviet Union sent their heavily armored Venera landing probes to explore the surface, the extreme pressure and heat crushed and melted them within hours. The runaway greenhouse effect is an accelerating death spiral. It permanently locked Venus into a fiery state from which there is no planetary return. While the surface is dead, the story might not be over. 30 miles up into the thick clouds, the crushing pressure drops and the temperature cools to something similar to a spring day. These side-by-side images show the complex cloud patterns of Venus in both visible and ultraviolet light. Deep within these swirling layers, astronomers have recently detected traces of phosphine gas. Phosphine is unstable and breaks down quickly. On Earth, this specific gas is generated almost exclusively by living, anaerobic microorganisms. This detection led astrobiologists to a radical theory. As the surface oceans boiled away, simple Venusian microbes may have been swept up by the winds, migrating into the high-altitude clouds to survive. The very acidic clouds that suffocated the surface might serve as the last refuge for an ancient, alien ecosystem. To resolve this debate, NASA is preparing to deploy a new generation of spacecraft, including the Da Vinci and Veritas missions, launching in the coming decade. By studying a planet that died, astrobiologists can map the exact tipping points where a habitable environment breaks down into total system failure. On Venus, we observe the physical mechanics of a total planetary climate collapse. This world is a profound cosmic mirror, a chilling cautionary tale of what happens when a planetary atmosphere breaks down entirely.
Subscribe for more informative video like this and press the bell icon for latest notifications.